Our next step is to see how to move our data from Excel to Word. First, let's add borders, outside borders, to the column headers like so. Then let's drag select this area, and you'll likely have more data. You should have at least 5 different settings of ramp height for this one, for example, and add all borders. Now let's drag select, right click copy. We'll open Microsoft Word and right click paste, and we'll choose that first option, keep source formatting, like so. Recalling the exemplar from IB which includes an equation for the averaging of measurements, repeated measurements, and a sample calculation, and also an equation showing how to determine the uncertainty in the average and a sample calculation with real data. We'll do the same here. So we need to insert an equation, and here we have to be ready to type D average, but instead of just typing it DAVG, what we need to do is we need to use a template, this so-called script, and in our case a subscript will be needed. The D goes here, right arrow, AVG, right arrow on the keyboard, equals, and then next we'll need a fraction template, and on top we'll have another subscript, D, right arrow, 1, right arrow, plus. And to save a little time, what we might do is just go back and hold left shift, right arrow, control C, right arrow, whoops, left arrow to get back up there, and control V, plus control V, plus control V, plus control V. And I'll come back to these subscripts and just change them to the appropriate values. 2, oops, right arrow, right arrow, right arrow, right arrow, right arrow, right arrow. Let's see, delete 3, there we go. Some right arrows, delete 4, delete 5, there we go. And divided by 5, of course. Now we need to use quite a few right arrows, there we go. Looks like it's as many as you can do. Now that was a mistake. We don't want it to look like that, so let's go back. It looks like if you do too many right arrows, you actually leave this equation editing area. So let's go left arrow to the 5, right arrow, equals, good, we're still working here. Now what I'd like to do is, again, to meet this exemplar, I think I'll just copy this whole, I'm doing left and right arrows here, I guess I'm going to use the mouse now. Click and drag, there we go, Control C and Control V, good. And now I'll be ready to replace D1 with the actual D1 from trial 1, so Control C, let's just select that only, there we go, and paste it in. There they are. Let's use right arrow, whoops, down here, right arrow again. We went to the 5, right arrow one more time, right arrow one more time, equals, and again, if suppose you do too many right arrows, equals, oops, you just undo, that happens to me a lot, try equals again, there we go, and now simply the answer. This is the average roll distance. Oops, okay, sorry, there we go, so just undo and it looks good. And it's also good, I would say, looking at the exemplar, let's remember our units as well. We could be zapped for that by IB graders, so let's do it their way. We'll put parentheses around all of these. So parenthesis, click at the end, parenthesis, and just put the letter M for meters. And then make sure that you click to the end here and put meters there as well. using a similar process, we can generate the equation and sample calculation for uncertainty in average roll distance. Let's take a look at how we get our Greek letters. We know we need delta D average here. And it looks like we have symbols here, so we'll click the little button here for more. It says basic math. I'd like Greek letters, please, and delta looks good. And then D. AVG goes in the subscript box, right arrow, equals. And the rest is very similar. So I generated the formula for determining uncertainty in the average roll distance, copied it, and now I'll just again replace with the max value, here it is, etc. One detail I notice in the exemplar is that we have is approximately equal to symbol, a wiggly equal sign, and we may as well match that. We admit that this is not, the result is limited by significant digits, so we could put the wiggly equals in. On the other hand, just by the fact that we're only including 3 significant digits, we're already admitting the limitations of this measurement. So it's your choice whether you want to put wiggly equals or just a straight equal sign. Here's where we depart from the exemplar just a bit. We're going to insert a plus or minus symbol, which we find in basic math. There it is. And 0.08 parenthesis M. And notice the exemplar states T average plus or minus delta T average equals, which is true. But it's implied by simply saying D average equals this, that this is clearly the average value that we're stating, and this is clearly the delta D, the change in that, or potential change in the D average. So this is a better way to write it.